morning, students. Good morning. Today we will discuss about the examples of outer orbital complexes and inner orbital complexes. So here we know that when outer orbital complexes are formed by weak field ions. So weak field ions, if the weak field ions are present, pairing of electrons is not possible. If the strong field ions are there, pairing of electrons takes place. Therefore, pairing of electrons takes place, they can form the inner orbital complexes. So, if pairing of electrons is not possible, they form the outer orbital complexes. Here we are taking few examples and their structures and magnetic behavior. So it is based on VBT only. Valence Newton theory is explained. I have already given the inner orbital complexes and outer orbital complexes. Here we are discussing about few examples. Here, first example is CrH2O taken 6 times plus 3. So first example here, the oxidation state of chromium is plus 3. So here once you check it, oxidation state of chromium is plus 3. How plus 3? 6 plus 3 here. So here this neutral ion, therefore its oxidation state will be plus 3. So hybridization, in case of complex compound, how many number of ions are there? Then we are considered, that is the hybridization. Here 6 ligands are there. Therefore, 6 ligands means sp3 D2 is possible, D2 sp3 is also possible. So, two type of hybridizations are possible for that. First one is sp3 D2, second one is D2 sp3. So, we know that one, if the coordination number is 6, the shape is octahedral. So, we know that one. After that one, chromium plus 3 means how many unpaired electrons are there here? Cr 3d5 4s1. So 3d5 4s1 means 1 electron from s orbital, 2 electrons from d orbitals are removed. Therefore, it has 3 unpaired electrons. 3 unpaired electrons. Due to presence of 3 unpaired electrons, it exhibits paramagnetism. So it is high spin compound or low spin compound? It is a high spin compound. So here high spin means it has unpaired electrons. Here 3. How 3? Because chromium oxidation state is plus 3 here. Therefore 3d5 4s1. So 1 electron from s orbital, 2 electrons from p orbitals are removed. After removing 2 electrons from p orbital, 1 electron from s orbital, it has 3 unpaired electrons. Therefore, after that, second one, NiCl4 minus 2. Here the oxidation state is plus 2, we know that one. sp3 hybridization. So sp3 hybridization means tetrahedral shape. So it is also utilizing outermost orbital. Therefore 2 unpaired electrons are there. How 2 electrons? If you calculate the net plus 2. Oxidation number, we get 2 unpaired electrons are possible. Therefore it is paramagnetic in nature. Next one, metal carbonyls. Metal oxidation state is 0. So what happened here? The shape of the molecule is tetrahedron and vibration is sp3. Because of neutral ions, there is no possibility of unpaired electrons. So they are considered as metal carbonyls. So in metal carbonyls, oxidation state of metal is 0. Therefore, it has diamagnetic in nature. Diamagnetic means it doesn't have any unpaired electrons. Therefore, metal carbonates are diamagnetic in nature. It is also explained by VBT, valency bond theory. So after that, I will take one more example, MnCl4 minus 2. So first you know the manganese oxidation number, manganese electronic configuration. If you are removing 2 electrons, 3 electrons, how it exhibit? So MnCl4 minus 2 here plus 2 sp3 tetrahydral 5. Unpaired electrons are 5 unpaired electrons are there. So Mn plus 2 is 3d5 4s2. The electronic configuration of manganese is 3d5 4s2. So if you are removing 2 electrons, means s electrons are removed, therefore it has 5 unpaired electrons. Mn plus 2 has 5 unpaired electrons. Therefore it has 5 unpaired electrons, therefore it exhibits paramagnetic nature. So these are very important in NEET level or exam level. If you know this, if you done so many examples, you can got complete idea. If you are doing only 1 or 2 examples, you don't have any complete idea about that level. So that's why you can do more and more examples. You take so many complex compounds. That's why I am giving here more than 10 examples I have given here. Because in this they will ask you hybridization, you got confusion. If you do more problems, you don't have confusion because similarity is observed in the problems. Similarity means if you do few problems, you got similarity. So to avoid the similarity, you can do more and more problems. So here, MnCl4 minus 2 here plus 2 sp3 tetrahydral 5 paramagnetic in nature. After that, FeH2O taken 6 times plus 2 here oxidation state is plus 2 sp3 due to hybridization octahedral. Number of unpaired electrons are 4. 4 unpaired electrons means paramagnetic in nature. Paramagnetic nature. Therefore, the shape of, because octahedral means if the 6 ligands are bonded around the central atom, then its hybridization is sp3d2 or d2 sp3 hybridization. If it is outermost orbital complex compound, then its hybridization is sp3d2. If it is inner orbital complex compound, its hybridization is d2 sp3. So d2 sp3 means inner orbital complex, sp3d2 means outer orbital complex. That is the difference. So here sp3d2 means simply we are saying that is outer orbital complex compound. It utilizes outer orbital complex. So that's why here octahedral shape is possible because 6 ligands are there. Because of presence of 6 ligands, the shape is octahedral. After that, FeNH3 plus 2, 6 plus 2. So oxidation state is plus 2, octahedral, 4, paramagnetic in nature. So in exception cases, this is also plus 2. Say Cr, some cases, so sp3d2 octahedral 4. So number of unpaired electrons are 4 are possible. Fe plus 2. 3d6 4s2. 3d6, therefore how many electrons are removed? Fe plus 2. Fe plus 2 means 3d6 4s 0. So 4 unpaired electrons are possible. Here Fe plus 2. Fe plus 2 means 3d6 4s 0. Therefore 3d6 means 4 unpaired electrons are possible. Therefore paramagnetic nature. So Fe plus 2, this is Fe plus 2. If it is Fe plus 3, therefore 3d5, 4s 0. 3d5 means 5 unpaired electrons. So Fe plus 3 is more stable than Fe plus 2 because of stable electronic configuration. So this is about outer orbital complex compounds. So in case of outer orbital complex, few examples are diamagnetic also observed here. So actually these metal carbonates we are discussing, this is the special case here. Actually maximum outermost orbital complexes are paramagnetic in nature only. So these are diamagnetic. Exception cases are there here. Some examples also there. If unpaired electrons are there, they are exhibit paramagnetic nature. If unpaired electrons is not possible, so they are exhibit diamagnetic nature. So this is about outer orbital complex compounds. So how the outer orbital complex compounds are formed? I am already given two examples. I have taken two examples. I will explain about the VBT, valency bond theory. So now we will discuss about the inner orbital complex compounds. Here, in case of inner orbital complex compounds, first we are taking CrNH3 taken 6 times plus 3. In this compound, the oxidation state of metal is plus 3. It utilizes D2sp3. How it is utilizes D2sp3? You know that one? Because it is strong field ion. Because of strong field ion, pairing of electrons is possible. So after pairing of electrons takes place, what happened? The orbital complex compound is called as inner orbital complex compounds. If it has unpaired electrons, it exhibits paramagnetism. If it does not have any unpaired electrons, it exhibits diamagnetism. Here, unpaired electrons are possible for in case of this compound. Therefore, it exhibits paramagnetism. So paramagnetism is nothing but it has unpaired electrons. Therefore, it is considered as high spin compound. So maximum compounds in case of inner orbital complexes are low spin because orbitals are pairing up takes place based on the ligand. After that, FeCO4 5, it is DsP3 hybridization, trigonal bipolar 0 diamagnetic. FeCN6 minus 3, D2sp3 octahedral 1 paramagnetism. MnCN6 minus 4, oxidation state of manganese is plus 2 D2sp3 octahedral 1 paramagnetic nature. So here, if oxidation state of manganese is plus 2 but does not have 5 unpaired electrons because Cn6 is a strong field ion. Therefore, in case of strong field ion, pairing of electrons takes place. They come back to the inner orbital. Inner d orbital is filled with electrons. So inner d orbital is filled with electrons means what happened? Number of unpaired electrons number is decreases. Therefore, in case of here, the oxidation state of manganese is plus 2, but the oxidation state unpaired electrons are 5 here. But here same oxidation state is there, but the number of unpaired electrons is only 1. Why? Because here this compound is outer orbital compound. Here it utilizes outer orbital. So outer orbital means what is here? Cl minus is a weak field ion. Cl minus is a weak field ion means what happened? Pairing of electrons is not possible in case of weak field ion. Therefore, outer orbitals only utilizes to the formation of hybridization, to the bond formation. Only outer orbitals are utilized here. Therefore, it has 5 unpaired electrons. Do d orbital having unpaired electrons? But in case of here, it utilizes inner orbital. Therefore, number of unpaired electrons are decreases. Same thing here also. Cn minus is also sided is also strong field ion. It utilizes octahydrogen 0 diamagnetic and D2sp3 hybridization. So this is about outer orbital complexes and inner orbital complexes are there. Just once you check, so many examples are given. Which one is paramagnetic? It has unpaired electrons or not? high spin or low spin, diamagnetic or paramagnetic, how many unpaired electrons are there, what is the hybridization, due to sp3 or sp3 due to, how they are formed sp3 due to or due to sp3, like that you can do so many problems like this. So what is the basic thing here? The ligand present is and oxidation number and coordination number. To remember these three, based on this we can confirm the geometry of the molecule. If the number of coordination number is 6, its oxidation shape is octahedral. Coordination number is 4, sphere planar is possible and tetrahedral is also possible. You have to remember this. In case of metal carbonate, CO is there, maximum compounds are exhibiting tetrahedral shape with the coordination number 4. So in case of other substances, sphere planar is possible. If its coordination number is 4, sphere planar is possible. So that is also one of the important thing. So in which maximum in metal carbonates sp3 hybridization is there if that coordination number is 4 and the shape is tetrahedral. You have to remember this. In case of metal carbonates, if the ligands are Cl minus or Cl minus tetrahedral, sphere planar is possible, sphere planar, and dsp2 is possible, sp3 is possible, like that you can do it. So this is about, and also one of the important, without knowing the oxidation number, we can't find the shape, because how many electrons are utilized, how many electrons are takes place, how many unpaired electrons are possible. How to remember all this? By knowing all these things, it is very easy to identify the vibration and geometry of the molecule. This is about VBT and geometry of the molecules. After that, so we are taking few examples for square planar complexes, square planar and tetrahedral. I will give an example for this. Tetrahedral complexes. So I will take tetrahedral compounds. Tetrahedral compounds, I will take one example here. I will take NiCl4 minus 2. NiCl4 minus 2 here, one example. Here it is plus 2 sp3 tetrahedral, plus 2 sp3 tetrahedral and paramagnetic. This is same. I will take one more example. NiCl4 minus 2. NiCl4 minus 2. Here plus 2 dsp2 hybridization. dsp2 here and square planar and 0 unpaired electrons here, diamagnetic 0 2 here. So 2 unpaired electrons paramagnetic. This is the difference. So here it is weak field ligand, it is strong field ligand. So once you check, just you have to remember like this. Here utilizing sp3 hybridization, here dsp2, because if dsp2 hybridization square planar shape and pairing of electrons takes place, there is no possibility of unpaired electrons. That's why it can exhibit diamagnetism. In case of this coordination number is both 4, so tetrahedral shape. Once this is not considered constant, some examples are like this, tetrahedral and square planar. So that's why I am giving coordination number is 4, sp3's hybridization is possible and dsp2 hybridization is also possible. So based on the ligands, type of ligands here, weak field ligand is strong field ligand. This is about VBT and geometry and magnetic properties of VBT.